Hi, it's Mr. Anderson, and this is Chemistry Essentials video 28. It's on stoichiometry, which is really just measuring atoms. In other words, in a reaction, we're measuring the atoms we have before the reaction and after. And because of the conservation of mass, we have to make sure those are the same. And so it's a really powerful tool. Chemistry teachers love stoichiometry, and students not so much. And so let's think of it as musical chairs. As you're playing musical chairs, you're walking around the circle. And so you're kind of bonded to the floor, but when the music stops, you have to quickly find a chair. And when you do that, it's like a chemical reaction. You're breaking your bonds with the floor, forming new bonds with that chair. And if there's not enough chairs, then you're kind of out. In other words, chairs could be the limiting reactant in this reaction. And so sometimes we don't have enough chairs, and sometimes we don't have enough people. And so reactions are going to be the same way. And so basically, stoichiometry allows us to measure chemical reactions, but in order to do it, we have to have a balanced chemical equation. And so the coefficients in that equation are going to show us the number of moles, and so it's the mole proportion. So just this one idea is so powerful. If you understand it, you can answer so many different problems. But if you don't get it, then the following 5 things, figuring out expected product, limiting reactants, percent yield, molar mass of gases, and titrations are going to be really confusing. But the one thing that ties them all together is this idea that the coefficients in an equation represent the number of moles. And so as you watch this video, look for the commonalities. What's going to be the one thing that ties all 5 of these together? First thing, let's say we're trying to figure out the expected products. And so in this reaction, in the burning of methane in a Bunsen burner, we're combining methane gas with oxygen to make carbon dioxide and water. And so let's say you're given this problem. Given a certain amount of mass of methane, could you figure out how much water is produced? Well, the secret is going to look like this. We can go from the number of grams to the number of moles. We can then go through a mole conversion and then go back to grams again. And so you're going to see this over and over and over in each of these problem sets. And so the first thing you have to do is make sure that that equation is balanced. And so once it's balanced, then we're ready to go. That should always be your first step when you're doing stoichiometry. Make sure that equation is balanced. Then we start with what we know, and I always write that over 1 because it's easier to do these factor label methods. And so we've got 24.6 grams of methane. First thing you want to do is convert that to moles. How do we do that? We're going to use the atomic mass of methane. Remember, it's going to be the carbon, which is 12, and the hydrogen, which is around 1. And so this is going to be the formula mass of methane. And so now we've converted it to moles of methane. Next thing we want to do is we want to bridge the gap. We want to go from the methane over to the water. And so we're going to use a mole conversion to do that. So this 1 mole of methane is going to correspond to 2 moles of water. And so this is the secret of stoichiometry. We can use the numbers in front, these coefficients, and that's going to allow us to bridge the gap. So we've already converted it to moles of water. Now we can just go back to grams again. So we're going to use that mole conversion. In other words, water is going to have an atomic mass of 18.02 grams. So now we've gone to grams of water, and so we can quickly solve the problem. And so again, it's really easy to predict what we're going to get in a reaction just using the equation in the periodic table.
Guys, so we just went over the basics of stoichiometry, and now we're going to learn the magic number method. So go ahead and listen to this, copy it down in your notes, and at the end of the video we'll have a couple of problems to work on.
Stoichiometry made easy, the magic number method. This is a quick shortcut method for solving stoichiometry problems. Let's start with an example. Nitrogen and hydrogen gas combine to form ammonia. First thing you got to do is balance the equation. If you don't know how to do that, see another video or ask your teacher. We're going to assume you know how to balance a chemical equation. Okay. Now let's say the problem gives you 25 grams of nitrogen, and they want to know how many grams of ammonia would be produced if you have plenty of hydrogen. The magic number method goes like this. Put an X with every compound. You're halfway there. The next thing you do is out front, put the molecular weight of each compound. Nitrogen is 14 grams per mole, so N2 would be 28 grams per mole. Hydrogen weighs 1, so H2 would be 2 grams per mole, and ammonia would weigh 17. So put those numbers out front like you see here. Here's how it works. you simply solve for x. X is your magic number. 28x equals 25. So x equals 25 divided by 28, or 0.893. That's our magic number for this problem. It'll be different for every problem that you do. Here's how you use it. You want to know about ammonia. So, 17 times 2 times x. We know x, it's 0.893. You get 30.36 grams of ammonia. What if you wanted to know the grams of hydrogen that you need instead? Do it the same way. The grams of hydrogen would be 2 times 3 times x. Put in our magic number, 5.36 grams of hydrogen. It's just that easy. Now, you don't have to just solve grams. You can do problems with moles. Just leave the green numbers out. The green numbers are specifically for grams. So let's say instead you wanted to know the moles of hydrogen that you need. Well, it'd just be 3 times x, 3 times our magic number, 2.68 moles of hydrogen needed. What about the moles of ammonia? Again, leave the green numbers out. 2x, 2 times 0.893, 1.79 moles of ammonia. You can solve any stoichiometry problem this way.